I think we're going.
Oh, yeah.
Yeah,
We're
okay.
going. Hi.
Welcome back, part 2.
Part 2 of States of Matter and Phase Changes.
Phase changes.
Yeah. Sorry. I was a little spaced out. You know, I get so into I'm dreaming of science.
She's thinking of phase changes over here.
I am trying to explain this. So, of course, we want to put these notes into our science notebook.
Maybe label this part now phase changes.
And we were just discussing about that first part there. We don't think you really need to know the definition because you kind of know.
You know that.
Yeah. But we do think the examples are pretty important for you to know, especially the vocab, you know, with the evaporation, boiling.
Condensation.
Yeah.
That's new stuff.
Yeah. So let's make sure we remember when we melt, we're changing from a solid to a liquid.
Yep.
When we evaporate, when we boil, which we've done a lot of boiling because macaroni and cheese, you know.
You boil that water.
Yeah.
Yep.
At least I do. And then gas to liquid, that means we're going backwards.
Yep. That's your condensation.
That's when it's raining. And then liquid to solid, that's when we make our ice cubes.
Freezing.
Freezing. All right, here we go. Here we go. Oh, melting. Oh, yeah, the Wizard of Oz. Yeah, love that part. Phase changes require energy.
Oh, boy. Yeah.
So energy goes back to last semester.
That's been a long
we
time
learned
ago.
about heat energy.
Yes.
And energy's absorbed in melting and evaporating. That means it's taken in.
Yep. So it's going to take in energy when you need to melt and evaporate.
That would be boiling also, would be evaporating. And then energy is let go or released when we're going from a gas to a liquid, which is condensation, and when we're going from a liquid to a solid, which is freezing. Those are kind of key things. We really want you to write those things.
Got to remember that.
Yeah. Energy. Oh, yeah. I remember that law.
Oh,
There's
gosh.
that law of conservation of energy.
That's a big one.
We don't create it. We don't destroy it. We're just moving it.
Moves from one place to another.
Oh, I don't think we need to copy that diagram down, but that is showing you. You can see that at the bottom here. I'm going to use my little mouse here. Down here, it's a solid, and then I'm going to absorb energy to become a liquid, and I'm going to absorb more energy to become a gas.
Exactly.
And then we go reverse the other way. When I'm a gas, I'm going to release energy to become a liquid, and when I'm a liquid, I'm going to release energy to become a solid. Nice. I love that diagram. That's kind of nice. Okay, transferring heat. Now remember we're not creating or destroying. We're just going to transfer the
move
heat.
it
We're
one
gonna move
place to another.
It always moves
From higher to lower.
Yep. That's like saying I can only give my money away if I have a lot of it.
No.
So
I
it's
like
kind
that.
of hard to give away money when you don't have it.
That's true.
So that would be the low energy.
Yes. I don't have any money. I can't give you anything.
So nothing freezes up. You don't get cold.
You go from higher energy to lower energy.
So you give your energy away. You never gain that. Okay. So we have an example here. You might want to pause and take a look and read at this. But we have 50 grams of 90-degree metal into 50 grams of 30-degree water. After 10 minutes, what will the temperature be? Well, we're going to pause that.
Let's pause.
And we will come back.